Okay, so hi everybody. So today our lesson is going to be over arithmetic sequences. It shouldn't take too long. Okay, so let's just jump right into it. Okay, so arithmetic sequence is a sequence with a constant difference d, okay, between the terms. We find this d by taking any term in the sequence, as long as it's arithmetic, and subtracting it from the prior term. That is given the sequence A1, A2, A3 all the way up. You're going to have D is equal to AI minus A of I minus 1. Now, what's this I stuff, okay? So if you look here, I have a sequence A1, which represents the first term, A2, which represents the second term, A3, which represents the third term, and then so on. Somewhere along there, I'm going to represent, I have this AI. Okay, I just represents a single number. And the number that comes right prior to it is A of I minus 1. So to find the common difference, you take any term in that sequence, which I'm just representing as AI, and you subtract AI minus 1 from it. Okay? So let's just practice a few of these to figure out if they're going to be arithmetic. Now, if it's going to be arithmetic, the difference between any two consecutive terms has to be the same. Okay, so you can see here that this one, 1, 2, 3, 4, 5, it goes up by 1, goes up by 1, goes up by 1, goes up by 1. So yes, this is arithmetic with D is equal to 1. Now, that one's really easy, right? You can obviously see it goes up by 1, but what happens if you didn't see that? Okay, if you couldn't see that, you take any term in this sequence and you subtract it from the prior one to determine what that common difference is. So I'm going to go D is equal to, I don't know, I'll pick 4. 4 minus 3 gives me 1, okay, which gives me the common difference of 1. Okay, so these go by pretty quickly. Does this sequence represent an arithmetic sequence? So from 3 to 8 is 5, from 8 to 13 is 5, 13 to 18 is 5, 18 to 23 is 5, and so the answer here is yes, it is, with D is equal to 5. Once again, if I didn't see that, I could go D is equal to pick any term in here, so I go 13, so 13 minus 8 is going to give me 5. Okay, next one. Does the sequence 2, 4, 8, 16, 32 represent an arithmetic sequence? No. You might think it does because it has a pattern, but it doesn't go up by the same amount each time, right? This goes up by 2, and then 4, and then 8, and then 16, and so on. And so since it goes up by a different amount each time, the answer is no. Now, if you're asked to explain that, the way you explain it is you would say, well, 8 minus 4, any term in that sequence minus the prior one, is not equal to 32 minus 16, not equal to. Okay, so because if it is an arithmetic sequence, the common difference anywhere in there should be the same. Here this is 4, and 4 does not equal to 16. Okay, next one. Does the sequence represent an arithmetic sequence? So 4, 2, 0, negative 2, negative 4. So if you notice, you're going down by 2 this time, so it's okay to go down. So you're going down by 2 each time, so the answer is yes. And you might say that D is equal to 2 because it's going down by 2 each time. But the answer is not 2. It is negative 2. Negative represents that it's going down. Once again, if you didn't see that, take any term in this sequence. So I'm going to go the last one, negative 4. So negative 4 minus the prior one, negative 2, which turns it into plus 2, gives you negative 2. Okay, so that's just determining if it's arithmetic or not. Okay. Finding a recursive rule for the nth plus 1 term. So in order to do this, all this is doing is just simply saying, can you come up with a rule based off of what happened right prior to it? Okay, so if you think about what this means, A of n plus 1, that just represents the nth plus 1 term in that sequence. All you're going to do is you're going to take the prior one and add D to it. That's it. Okay, so this is pretty simple. If you notice here, this is what we had. This is the same sequence we had up above, where D is equal to 1. So the recursive formula, in order to find any term in that sequence, you're going to take the one that comes just prior to it. So that's A of n plus 1. That's A of n, so this one comes just prior to it. And you're going to add on what would be the common difference. In this case, it's 1, and that is it. Okay, so doing this one, we also figured that that was equal to 5. So I have a of n plus 1 is equal to a of n plus 5. That's it. Okay, once again, to get any term in the sequence, all I need to do is go to the one prior to it and add what would be on the common difference. Okay, next page. Flying through this. Okay, find the recursive formula for the sequence 4, 2, 0, negative 2, negative 4. Once again, here we figured out that d is equal to negative 2. So a of n plus 1 is equal to a of n plus a negative 2. So that's just minus 2. Okay, and that's what our answer is. Okay, that's our recursive formula. Recursive says I'm relying on what came just prior to that. Okay, an explicit formula is say I'm going to come up with the formula and I want to know what the 2000s term is. All I need to do is plug 200 in that formula and it will give me what that value is going to be. Okay, so here, if you think about how this works, you have a bunch of terms, right? So this is A1, this is A2, A3, A4, A5, and then so on. Now, A1 represents the first term. In order to get to the second term, I'd have to add D once, right? To get to the second term, I'm going to have to add D once. And so this is going to be A1 plus D. Now to get to A3, you're going to go to A1 and you're going to add on D 2 times, so plus 2D. And then the pattern continues. To get to this, you're going to have to go to A1 and add it 1, 2, 3 times. So if it was A4, I have to add D 3 times. If it was A3, I'd add D 2 times. A2, I'd have to add it 1 time. So it's always 1 less than whatever the value is, which is where this equation comes into play. So to figure out any term in that sequence, you take the first value. Let me zoom in a little bit. You take the first value, and you're going to add on D n minus 1 times. Okay, so let's go down and let's do some examples. Find the explicit formula for the sequence this, then use it to find the 20th term in the sequence. Now, hopefully you should recognize what the 20th term is. The first term is 1, the second term is 2, the third term is 3. So in other words, this A of 20 should be equal to 20. Oops, sorry. Okay, so A of 20 should be equal to 20. So let's go in through and we'll figure out what this is. Now, we figured out earlier that D was equal to 1. So according to this formula, I have A of n is equal to A of 1, but A of 1 is 1, plus n minus 1 times the common difference D, which in this case is 1. So A of 20 is equal to 1 plus 20 minus 1, which is equal to 1 plus 19, which is equal to 20, which is exactly the answer that we thought we'd get from the very beginning. Okay, so A of 20 turns out to be equal to 20. Okay, next question. Find the explicit formula for the sequence 3, 8, 13, 18, 23, and so on. Okay, once again, we knew that the common difference here was 5. So I have A of n is equal to A of 1, which is 3, times n minus 1 times the common difference, D, which in this case is 5. And so now, so this is what my equation is. So now I want to use this to calculate what the 30th term is. So just plug it in. So A of 30 is equal to 3 times 30 minus 1 times 5, which is equal to, this should be plus. I don't know why I left that off there, you guys. Sorry. The formula up there is plus. See? Okay, so coming back down here, I'm going to 3 plus 145. I did a lot of multiplication there in my head. I also did this earlier. So when you reduce this, you get 29. 29 times 5 is going to give you 145. So it turns out this is equal to 148. So the 30th term in this sequence is 148. Okay. Okay, example 1.4.10. Find the explicit formula for the sequence 4, 2. Okay, so we figured out that D is equal to negative 2. So we should have a of n is equal to a of 1, which is 4, plus n minus 1 times the common difference, which is negative 2. And there's your equation. Now we need to figure out what the 12th term is. So a of 12 is equal to 4 plus 12 minus 1 times negative 2, which is equal to 4 plus 11 times negative 2, which is equal to 4 minus 22, which is equal to negative 18. So the 12th term of that sequence is equal to negative 18. Okay. Let's do something a little more challenging. Okay, we only got 3 questions left. Okay. So find the 9th term given that u1 is equal to negative 40 and d is equal to 100. Well, hey, I have everything I need to know. If I want to figure out the 9th term, I'm just going to use this formula. So I have a of 9 is equal to a of 1. Oh, but a of 1 is negative 40. Plus n is 9. N minus 1 times d, which is 100. So this is negative 40 plus 8 times 100, which is equal to negative 40 plus 800, which is equal to 760. Okay, so pretty simple. Okay, now what about this one? Okay, so find the missing terms of the arithmetic sequence. So you notice they give you what A1 is, and they ask you to find A2, A3, A4, and then they give you what A5 is. Well, I could actually plug it into that formula, right? So I have the formula a of n is equal to a of 1 plus n minus 1 times d. And a of 5 is negative 22. So, and I'm going to do this another way because I think there's a slightly easier way to do it, but right now I'm going to try and use the formula. So I have a of 5 is equal to a of 1, but we know a of 1 is 2, plus n was 5, so I have 5 minus 1 times d. Now a of 5 is negative 22. So negative 22 is equal to 2 plus 4d minus 2 minus 2. Negative 24 is equal to 4d. Divide both sides by 4. So d is equal to negative 6. So the common difference is you're going down by 6 each time. So a2 is going to be equal to a1 plus the common difference. So a2 is equal to a1, which is 2, plus the common difference, which is negative 6. So this gives me negative 4. So a of 2 is equal to negative 4. Now, hopefully you can see I'm just going down by 6 each time. So now I'm just going to subtract 6 from this to get a3. So a3 is equal to negative 4 minus 6, which is equal to negative 10. And then a4 is equal to negative 10 minus 6, which is equal to negative 16. And if I wanted to go further, I don't need to, but I just want to show you that we're on the right path. A of 5, which I know is negative 22, is equal to negative 16 minus common difference, which is 6, which is negative 22. Okay, so we got everything right. Okay, so A2 is negative 4, A3 is negative 10, A4 is negative 16. Okay, and then the last one. Okay, so given that A3 and A5 are these and this, find A1 and AD. Now, I actually forgot to do this the easier way up here. I ran out of room, so I'm not going to do it up there. But I'm going to show you the method I would normally use, not even utilizing these formulas. I actually don't like memorizing formulas at all. I like to just understand it logically. So here's what I do with this. What I do is I draw in what would be A1, and then A2, and then A3, which I know is 5. And then I have A4, I have A5, which I know is 11. Okay, so what I need to do is I need to figure out what this is. I need to figure out the common differences. Now, if you think about what happens to get from there to there, I need to add D. And then to get from there to there, I have to add D as well. So in other words, if I took 5 and added D once, twice, it should be equal to 11. So 5 plus 2D is equal to 11. So subtract 5. So I have 2D is equal to 6. Divide both sides by 2. So I have D is equal to 3. Okay, so I figured out what that is. Now I need to go backwards. Okay, now going from A3 to A4, you just have to add on the common difference. But if I'm going backwards, I'm going to subtract off the common difference. So 5, the common difference is, I don't know why I did that. So I have to subtract the common difference. Okay, so this is 5. The common difference is 3. So 5 minus 3 is going to give you 2. And if you do it again, 2 minus 3 is going to give you a negative 1. So A1 is equal to negative 1, and D is equal to 3. Okay, so there we are. Hopefully you guys understood that. Good luck on your homework. And if you have any questions, please reach out to me so I can help you along. Okay, take care, everybody.